FastMCP3's tool Decorator mechanism enables metadata augmentation and execution constraint specification through parameterized decoration, extending the basic function signature with operational directives like timeout thresholds. This particular artifact demonstrates how the @app tool Decorator accepts a description parameter for natural language documentation and a timeout parameter to enforce maximum execution duration, both critical for tool governance in production environments. We are about to examine a concrete implementation where a search tool receives these decorative enhancements, establishing both its behavioral documentation and temporal boundaries before any invocation logic is defined. The setup pattern here initializes the tool's contractual interface while deferring implementation details, a common practice in interface-driven development.
@app, tool description equals search contacts by name or email, timeout equals 10, 0. Def search query, SDR list dict.
This code demonstrates how to add metadata and timeout settings to tools in FastMCP3. The @app tool Decorator is enhanced with a description parameter that provides human-readable documentation about the tool's purpose, and a timeout parameter that sets a maximum execution duration of 10 seconds. This metadata improves tool discoverability and ensures predictable performance by preventing long-running operations from hanging. The pattern shown here is particularly useful in production environments where tool reliability and documentation are critical. By explicitly setting timeouts, you prevent resource exhaustion and create more resilient systems. The descriptive metadata also enables better tool selection in AI workflows where multiple tools might serve similar purposes. This approach balances flexibility with control, allowing developers to optimize both functionality and system stability. When implementing this pattern, consider that overly aggressive timeouts might prematurely terminate legitimate long-running operations, while overly generous ones could allow problematic tools to consume excessive resources. The 10-second timeout shown here suggests this is intended for relatively quick operations like database queries rather than intensive processing tasks. Let's break it down line by line.
@app, tool description equals search contacts by name or email, timeout equals 10, 0. Def search query, SDR list dict.
Defines a tool-decorated function named search that accepts a string query parameter and returns a list of dictionaries. The decorator specifies a description, search contacts by name or email, and sets a 10-second timeout for execution. The @app tool Decorator in FastMCP3 elegantly combines metadata augmentation with execution constraints, establishing both documentation and runtime boundaries in a single declaration. By parameterizing the decorator with description and timeout, you create a self-documenting tool interface that enforces predictable behavior, critical for production reliability. The 10-second timeout here signals an expectation of quick operations, balancing responsiveness with resource protection, while the descriptive metadata ensures the tool's purpose remains clear in AI-driven workflows. This pattern embodies interface-driven development, where contractual obligations are defined upfront, leaving implementation details flexible yet governed. The trade-off between timeout strictness and operational needs becomes a deliberate design choice, reinforcing system resilience without sacrificing functionality.
The search products tool vows idempotent widgets, yet prices pirouette through every identical query.